This video gives some tips for solving rational formulas. First, you want to focus on using opposite operations. So if we want C by itself, you can look at what's happening to C. C is being divided by D, and then 1 is being added to it. So to oppose that, we take the last thing that was done and oppose it. So we want to subtract the 1 that was added, leaving us with A over B minus 1 equals C over D. But now the C was being divided by D, so we could actually multiply everything by D. But if you multiply this by D, you have to multiply all parts by D, leaving you with AD over B minus D equals C. So C is alone, great. If you want to simplify this a bit, you could make it a common denominator, leaving you with AD minus BD over B. Those are equivalent. Both of those would be correct. If you really wanted to, you could factor the top. So that'd be D coming out. A minus B over B equals C. All three of these would suffice. C is alone. That's the main point. Here, x is trapped in some more operations. We've got x plus y, all times b, and then all divided by 2. So the last thing that was done was division by 2, so we want multiplication by 2. So we'll have 2a is equal to x plus y times b, because the 2 now is gone. But we want x alone, so we've got bracket times b, so we want division by b to eliminate the b, leaving us with 2a over b is equal to x plus y. We still need x alone, so we can subtract y, leaving us with 2a over b is equal, or subtracted by y, is equal to x. And again, you can play around with the way you present it. You could get a common denominator. So you'd have 2a minus yb over b is another way of writing that same formula. Another thing to keep in mind is to keep the variable in the numerator. In the previous examples, they were all in the numerator, but in here, you can see that this is actually in the denominator. The C is in the denominator. So what we need to do now is we need to get it out of the denominator. And to do that, what do? You could multiply everything by C. You could actually multiply everything by ABC if you wanted to get rid of all the denominators. So if you just multiplied by C, you'd get C over A plus C over B is equal to 1. Great, but now we need to get C together by itself. Again, if this fraction thing is bothering you, you can actually multiply through by AB. So times AB, times AB, times AB. That's the common denominator. You could have done ABC at the beginning. So now you can see that you'd have CB plus CA equals AB. Okay, but we need C alone. So we actually need the variables in one place if they're in two places, so that then you can factor out your C and then you can get it alone. So we've got C times B plus A equals AB. So if we divide both sides by B plus A, then we get C equals AB over B plus A. And we have C alone. Similarly, we could actually do this very much the same way with this next one. It's the same formula. We want to solve it for B. So let's just try getting rid of the denominators right away and multiplying through by the lowest common denominator. If we multiply everything by ABC, this is what we'll have left. We'll have BC plus AC equals AB. which is the same as this part. Now we want b alone, so we want b all by itself. So we have bc, and let's get our b terms together. So it'll be bc minus ab equals negative ac. So we subtracted the ac from both sides and subtracted the ab from both sides. Now we can factor the b out, which gives us c minus a. It's a very important trick to have up your sleeve, is to get your variable together into one area so that you can factor it out so that it's in one place, not two. So now you can divide both sides by c minus a, and you have b equals negative ac over c minus a. Again, remember, if you want this in a different direction, you can always take out a negative, and that'll make the a positive and the c negative, which then becomes ac over a minus c. So all three are correct, they're just different ways of writing the same thing. So finally, we've already covered this, but let's just look at a couple other scenarios of it. Is if your variable's in different places, you want to bring them to one place. And that's very important. So let's take a look at this example here. We want t by itself, so let's first get it out of the bottom. So to do that, we need to multiply by the denominator, 1 plus at. So that'll leave us with p, bracket, 1 plus at equals at. Now, let's multiply that out, distribute. So we get p plus, this is a p, apt. The order doesn't really matter there. I'm just trying to keep it as alphabetical as I can. So now our t is in these two terms, so we want to bring those two terms together so that we can factor the variable out and then get it by itself. So if we subtract the apt term from both sides, then we get p equals at minus apt. Factor out the t, you have a minus ap. And then now, because t is alone, and that's a multiplication by a bracket, you can divide both sides by the bracket, and you have t alone. P over a minus ab. And finally, try it with this last one. It's a very similar process. We want n by itself, so we multiply that there as well. So that'll be, if you distribute that, you'll have I n r plus IE equals NE. And again, we want n by itself, so we want to bring our terms together. That'll be I n r minus NE equals, bring that other term over, minus IE, so they're isolated. Now take the n out, which leaves IR minus E. And now you can finally divide by this bracket, leaving you with n equals negative IE over IR minus E. So those are the key three things to take a look at, is to make sure your variables are in one place, kept in the numerator, and you oppose your operations.